Okay, so how we can make a connection if we do a computer simulation? How can we make a connection of the simulation results? How do we trust the simulation results? And this is the link um, uh, what a computer simulator makes with the experimental data. So let's say we have a real system here. So this real system could be a biological system, or it could be a liquid system, um, or anything of your interest. So you start from this real system, and starting from this real system, you make a model. This is very important. You make a model. You make a you make a model to obtain a model system. So what do you mean by making a model? So as I said that you make a model of water by describing that it has hydrogen, oxygen, hydrogen. It has HO bond, it has OH bond, it has a HOH angle, and it has partial negative charge on oxygen and partial positive charge on the two hydrogens. So you make the model, and that's your model system. Once you have the model system, you can perform computer simulation on your model system. Once you perform the computer simulation, you get the results. So those are the results you obtain from computer simulation for the model system you have made. On the other hand, from real system, you perform experiment and you get the experimental results. So experimental results are the accurate results what you get from experiments. And in this side, you got the results from your model system by carrying out a computer simulation. Now what you do, you basically okay, now you apply statistical mechanical theories from your computer simulation data, and using the statistical mechanical theories, you generate the same thermodynamic quantity for which you have the experimental data. Now you compare your experimental data with the data you obtain from computer simulation and statistical mechanical theories, and if they compare very well, then you can say with confidence that my model system was very good. If your results do not match, then you need to go back here and remake your model. So then your model was not good, and so your model needs to be remade. So you remake your model, make a new model system, perform computer simulation, get the data, apply statistical mechanical theories to obtain the experimentally known thermodynamic quantities, match them, and now if they compare very well, so you know that your model system is pretty good. So that is how you basically make sure that your computer simulation method was robust. So once you get a good match of the quantities for which experimental data are available, so you know that my simulation protocol and my models are good. So once you get that confidence that my computer simulation was good, so you can further go deep inside and obtain more information of the system which were otherwise difficult to obtain experimentally. In other words, what I try to say is that first you match your simulation data with available experimental properties, Once you see that they are matching pretty well, so in the next step you can attempt you can attempt to provide more insights on the complex systems for which on the complex system or phenomena which were difficult to obtain experimentally. So, that is the robustness of computer simulation technique. So, in computer simulation technique, to some extent also make a bridge between the experiment and theory, in a sense that once you make the model and you see that your model is doing pretty good by matching with the experimental data, you can also construct approximate theories on the model system, and from there you get the theoretical predictions. And if you now compare your theoretical predictions with the exact result from computer simulation, so that is a test of theory. So, it is said that in a sense computer simulation makes a bridge between the experiment and the theory.